Using Maclaurin series, write down the expansion up to the fourth power of Roman 1 cos x and Roman number 2 1 over x, 1 over 1 plus x. Hence, show that cos x over 1 plus x is equals to 1 minus x plus x squared over 2 minus x cubed over 2 plus 13x to power 4 over 24, isn't it? So to get Maclaurin series, you start with the Taylor series expansion of x minus a. So remember, when you have, we start of f of x plus h to be equals to f of x to be equals to f of a, it's an logarithm to help you with the expansion, isn't it? So if you want to expand the function f of x, then you take this part, isn't it? So when you are expanding f of x, you start from f of a, isn't it? Then in Maclaurin series, a is 0, isn't it? In Maclaurin series, you take a to be equals to 0. So it means the Taylor series expansion of f of x, we start from f of a. The Taylor series expansion of f of x plus h, we start from f of x. Are we together? So this is the part we want. When we are going to expand f of x, we start from f of a. So we are going to have, for you to expand f of x, you start with f of a, then plus, you differentiate it for the first time, leave a space where you are going to put the x, then plus, you differentiate it for the second time, you leave a space where you are going to put the other term of x, then plus, you differentiate it for the third time. Remember, you were told 4 terms up to the fourth power of x, meaning that you differentiate for the fourth time, isn't it? So if you differentiate it for the fourth time, let me create more space here, then plus the fourth time, f raised to power 4, then you start. When you don't differentiate it, it means that is 0 factorial. 0 factorial is 1, isn't it? If you differentiate it for the first time, it means that is 1 factorial, isn't it? So when you have 1 factorial, it means your x minus a is raised to power that 1, isn't it? Then the next one, if you differentiate for the second time, it means you have 2 factorial, isn't it? And 2 factorial implies your x minus a is raised to power that 2, isn't it? Then the next one, if you differentiate it for the third time, it means you have 3 factorial, isn't it? And 3 factorial implies you have x minus a raised to power that 3, isn't it? If you differentiate it for the fourth time, it means you have 4 factorial, and your x minus a is raised to power that 4. So that is just a logarithm of mastering the formula, but we knew what the formula was coming about, isn't it? So they are talking about the Maclaurin series. So in Maclaurin series, what do you know in Maclaurin series? A is equals to 0. So when a is equals to 0, what do we have? We have f of x is equals to f of 0, isn't it? Plus f prime of 0 over 1 factorial x minus 0 is just x, isn't it? Then x raised to power 1, then plus f double prime of 0 over 2 factorial, then x squared because it is x minus a. A is 0, isn't it? Are we together? Then you move on, then it is plus f triple prime of a over 3 factorial, then x is cubed. A is 0. You move to the next one, s, the fourth derivative of a, which is 0 over 4 factorial, then your x is raised to power 4 because x minus 0 is just x. Raised to power 4. After that, you now start. The first one you be told to expand is cos x. So it means the first part, you've been told if your f of x is equals to cos x, so if you differentiate cos x, f of x for the first time, differentiating cos x, you get negative, isn't it? Then if you differentiate it for the second time, what do you get? It is sine x you are differentiating, isn't it? Negative is outside. If you differentiate sine x, you get cos. Are we together? Is that okay? Yes. Good. You go on. If you differentiate it, for that, Third time, what do you have? If you differentiate cos x, negative sine x. So negative sine x times the negative which was outside, positive sine x, isn't it? Differentiating cos x gives you negative sine x times our negative which was outside. Then if we differentiate it for the fourth time, if you differentiate sine x, you get cos x, isn't it? Then after that, we need when f of a, f of where there is x, you put a, isn't it? So it means your f of a is cos a, isn't it? See where there is x, you put a. F prime of a is negative sin a, isn't it? F double prime of a is negative cos. Where there is x, you put a, because we are looking for f of a first, isn't it? Then you move again, f of f triple prime of a is sine a. Then f fourth derivative of a is cos a. Then after getting f of a in Maclaurin series, a is 0, isn't it? Yes. So where there is a, you put 0. So f of 0 is cos 0, which is, then f prime of 0 is minus sine 0, which is, cos 0 is 1, sine 0 is negative, sine 0 is 0, so negative 0 is just 0, isn't it? You move here, f double prime of 0 is negative cos 0. Negative cos 0 is negative 1, if you press that in the calculator, isn't it? Are we together? Yes. Because cos 0 is 1, so negative cos 0 is negative 1, isn't it? Yes. Move on, carry on. F triple prime of a, where there is a, you put 0 for Maclaurin series. So f triple prime of 0, you get sine is the same as sine 0, isn't it? Which is 0. Then f raised to power 4 of 0 is cos 0, isn't it? Which is 1. Are we together? So, see, the next thing we do is we substitute. We substitute our f of x for that. When f of x is cos x, we want to see the expansion of cos x, isn't it? So f of x, where there is f of x, you put f of x, which is? F of x, which is what? So where there is f of x, you put the f of x, which is cos x, isn't it? To be equals to f of 0. What is f of 0? Where there is f of 0, you put the value of f of 0, which is 1, isn't it? Move to the next one. F prime of 0 is 0, meaning the whole of this term will go to 0. Are we together? Then you move to this one, isn't it? F double prime of 0 is negative 1, isn't it? So negative 1 divided by 2 factorial, so it means that one you're going to get negative a half. Then your x is squared, isn't it? We are substituting. Tuko pamoja? Then you go here, f triple prime of 0 is what? Is 0, meaning the whole of this term is going to 0. Are you seeing that? Because 0 times everything is 0, isn't it? Then you go here, f fourth derivative of 0 is 1. So you have 1 over 4 factorial. What is 1 over 4 factorial? 1 over 24, isn't it? See, 4 factorial is 24. Yes. 1 over? So it is plus 1 over 24. Then your x is raised to power. So have you seen, you found the expansion of cos x up to the term in fourth power of x. Have you seen that? You found the expansion of cos. Are we together? You found the expansion of cos x. So that is what they expected you to get in Roman 1. So after getting the expansion of cos x in Roman 1, we now want to get the expansion of 1 over 1 plus x. Yes. Let us do that. That is Roman 2. Let us go back to the second part of that from where we started. So what have we found to be this? This expansion, cos x. We found it to be? 1 minus. We found it to be 1 minus a half x squared plus 1 over 24x raised to power 4, isn't it? So Roman 2, we now want to find the expansion of 1 over 1 plus x, isn't it? 1 over 1 plus x. So the Maclaurin series we've already written. So let us now write our Maclaurin series up here to give us more space. The Maclaurin series of the expansion f of x is what? Is f of 0 plus f prime of 0 over 1 factorial, x raised to power 1 is just x, isn't it? Then it is plus f triple prime of 0 over 2 factorial, then x squared, then it is plus f third derivative of 0 over 3 factorial, then your x is raised to power 3, isn't it? Then the last one, the fourth derivative of f of 0 over 4 factorial, x raised to power 4. So that is our Maclaurin series, isn't it? I need more space, that's why I've rewritten it up there. So after that, you now move again. What is our f of x now? So you come and write your f of x is equals to 1 over 1 plus, which is what? 1 over 1 plus x is what? So it is 1 plus x raised to negative 1, isn't it? It is 1 plus x raised to negative 1. Then you start differentiating. If you differentiate it for the first time, see you differentiate the outer. See, this one has a coefficient of 1. Are we together? Yes. See, this negative 1 times 1, you get negative 1 into 1 plus x, then you reduce the power by 1. Negative 1 minus 1, you get negative 2, isn't it? When you differentiate the inner function 1 plus x, you get 1. Because if you differentiate 1, you get 0. If you differentiate x, you get 1. So if you multiply it by 1, that is what you end up with, isn't it? Yes. So here we have 1 over 1 plus x. Then here we have negative 1 times 1 is negative 1 over 1 plus x squared. Remember, negative 2 means 1 plus x squared is in the denominator, isn't it? Yes. Is that okay? So we've simplified this. We move to the next one. If you differentiate it for the third time, we are differentiating the one which is in the form which is differentiable. This one, isn't it? Yes. Remember, this one is silent. The derivative within a function is just 1, so there's no need of writing it there, isn't it? Yes. So differentiate it for the second time. This is the part we are differentiating, but this is the simplest form of this, isn't it? Yes. So we differentiate the part which is written in a form which is differentiable, isn't it? Yes. We don't want to go to quotient rule, very involving, isn't it? So go here, negative 2 times negative 1, you get 2, then you reduce the power by 1. Negative 2 minus 1, you get negative 3. So what do you end up with? What do you get? In simplest form, it is going to be negative means it is in the denominator, isn't it? So we have a 2 over 1 plus x raised to power 3. This negative sign means reciprocal, isn't it? Yes. Then we differentiate it for the fourth. For the third time, which is the fourth derivative, isn't it? No, this was the second time. Then this one is the third time, isn't it? This was first, second, third time. So let us continue with the same process. For the third time, what do you get? Negative 3 times 2, you get negative 6, then x plus 1, then you reduce the power by 1, you get negative 3 minus 1 is negative 4. Derivative within a function is just 1, isn't it? So that one, if you write in the simplest form, negative 6 over 1 plus x raised to power 4. 1 plus x raised to power 4. So you are done with that. You differentiate it for the fourth time, isn't it? You differentiate this one which is differentiable, isn't it? Negative 4 times negative 6? 24. Then you reduce the power by 1. Negative 4 minus 1, you get? Negative 5, isn't it? Are we together? So after that, the derivative within a function is just 1, isn't it? So can you write in simplest form? It is what?
24 over
24 over
1 plus x
raised to power 5, isn't it? Are we together? After that, where there is, we want f of zeros, meaning where this x we put zeros for us to get the f of zeros, isn't it? Are we together? So the first one, start with the first one. F of 0, if you put 0 here, so you get 1 over 1 plus 0. What do you end up with to be f of 0? If you where there is x, if you put 0, you get f of 0, isn't it? So f of 0 is 1 over 1 plus 0, isn't it? Which is 1 over 1 is just 1, isn't it? Move to the next one, f prime of 0. If you put 0 where x is, f prime of 0 is negative 1 over 1 plus 0 squared. 1 plus 0 is just 1, isn't it? So 1 squared is 1. Negative 1 over 1 is? Negative 1. Are we together there? You go on, f double prime of 0, where there is x, if you put 0, what do you get? So it is 2 over 1 squared. So you get f double prime of 0 to be? Where there is x, you put 0, so you get 1 cubed is just 1, 2 over 1, so 2. Then we go here, f triple prime of x, where there is x, when you put 0, what do you get? What do you get? Where there is x, you put 0. So you get negative 6 over 1 raised to power 4. That is just negative 6, isn't it? Then the last one, f raised to power 4 of 0, isn't it? Where there is x, you put 0. So you get 24 over 1, which is just 24. Are we together there? So after getting all those, we substituted back in our formula, isn't it? So in our formula, f of x is what? 1 over. So where there is f of x, you put the value of f of x, which is 1 over 1 plus x, isn't it? 1 over 1 plus x to be equals to f of 0. F of 0 you found is what? Is 1. You write that. Then plus f prime of 0 you found is negative 1. So negative 1 over 1 factorial is just negative 1, isn't it? So negative 1 times x, this time you get negative x, isn't it? So you are done with that term. You move to this term. F double prime of 0 you found to be 2, isn't it? Are we together? So 2 divided by 2 factorial is 1, because 2 factorial is also 2, isn't it? So that is 1 times x squared. There you remain with positive x. You are done with this term, isn't it? Move to this term, f triple prime of 0 you found to be negative 6. Negative 6 divided by 3 factorial, you get negative 1, because 3 factorial is 6, isn't it? So negative 1 times 3x cubed, you get negative x cubed. Are we together? Are we together?
Yes.
Are we together? Then here, f raised to power 4, fourth derivative of x to power 0 is 20? 24 over 4 factorial is 1. 1 times x raised to power 4 plus x raised to power 4, isn't it? So we found that the Maclaurin series expansion of 1 over 1 plus x to be this, isn't it? Are we together? So the Maclaurin series expansion of the second case, 1 over 1 plus x is that. Let us write it there. Let us go back and record it, because we want to use it, isn't it? Let us go back and record it. So we found, let us write it here. We found the Maclaurin series expansion of this Roman 2, which is 1 over 1 plus x, is what? Is 1 minus x plus x squared minus x cubed plus x to power 4. So we found the expansion of this x, which was Roman 1 in Maclaurin series to be this, isn't it? We found the expansion of 1 over 1 plus x in Maclaurin series, which is that. So what do they want us to find? They want us hence to show that cosx over 1 plus x is this, isn't it? So you know that for you to get cos x over 1 plus x, that means it is cos x times 1 over, see, cos x over 1 plus x is cos x times 1 over 1 plus x. But when we've expanded, what have we found to be the expansion of cos x? We substitute, isn't it? The expansion of this cos x we found to be 1 minus 1 over 2x squared plus 1 over 24x raised to power 4. So you see we substituted for cos x. The next we substitute for 1 over 1 plus x, isn't it? So if you substitute for 1 over 1 plus x, what have you found to be the Maclaurin series expansion of that? It is this, isn't it? It is 1 minus x plus x squared minus x cubed plus x to power 4. Are we together? Remember, you are reaching up to the 4th power of x, isn't it? Meaning anything which is going to be a higher power you ignore. Are we together? Anything which is a higher power you ignore. So let us start multiplying them. When you start with this one must multiply everything on the other bracket, isn't it? So this one, if it multiplies everything in the other bracket, 1 times 1 is 1 minus 1 times x is that minus plus x squared minus x cubed plus x to power 4. We are starting with 1. This one must multiply everything on the other bracket. Isn't it? So we are expanding. So 1 times this, 1 times everything on the other bracket. So we are done with 1. Is that okay? We move to the next one. The next one is negative. This negative half squared x squared must multiply everything on the other side. So negative half x squared times 1, you get negative half x squared. Negative half x squared times negative x, you get negative into negative. Negative half x squared times negative x. Negative into negative is positive, isn't it? A half x cubed, isn't it? You move again. Negative half x squared times positive x squared, you get negative a half x raised to power 4, isn't it? Because x squared times x squared is x raised to power 4, you see? Then negative half 6 squared times negative x cubed, you are going to get x raised to power 5. You ignore that, isn't it? Yes. Then negative half x squared times x raised to power 4, you are going to get x raised to power 6. You ignore that. Are we together? Yes. So we are done with 1, we are done with negative half x squared. Then you move to the next one. Plus 1 over 24x raised to power 4, isn't it? So plus 1 over 24x raised to power 4 times 1, you get plus 1 over 24x raised to power 24. So this one times that. So when it multiplies other terms of x's, will be x raised to power 5 and above. You know all of them. Are you seeing? Yes. Meaning this times this will be x raised to power 5. We ignore this times that will be x raised to power 6. We ignore this times that will be x raised to power 7. We ignore this times that will be x raised to power 8. We ignore. We must only reach x raised to power 4 only. Anything else we ignore. So let us start collecting the like terms. Start collecting. Start with the constant. The constant term is that one, isn't it? Yes. Then go to the x power 1. This is minus x. It is only 1. Yes. It is only minus x alone, isn't it? Yes. So you collected it, so we collected this, we collected this, isn't it? Go to x squared. We have plus x squared minus a half x squared plus x squared minus a half x squared. Then the next one, only those. Yes. So if you factorize x squared outside, you have plus 1 minus a half into x squared, which is positive a half, isn't it? Isn't it? Yes. See, that is a half x squared, which is the same as x squared over 2. So that is plus x squared over 2. You are done with that. Move to the next one. We are going to x cubed. I go here. Minus x cubed and plus a half x cubed. What do you get? A total of? See, that is minus 1 plus a half into x cubed. Coefficient here is negative 1. Coefficient here is positive a half, isn't it? You get positive x cubed over 2, isn't it? Yes. So this is negative x cubed plus a half x cubed. So there, see that is negative 1 plus a half is negative. It's negative, isn't it? Yes. Negative 1 plus a half is negative x cubed over 2, isn't it? Move to the next one, that is x to the power 4. Look for the coefficient. The coefficient of x raised to the power 4 here is positive 1. Is positive 1. Then coefficient of x raised to the power 4 here is negative a half. Coefficient of x raised to the power 4 here is positive 1 over 24. So what is the total? What did you get there? Plus 1 minus half plus 1 over 24 is? Positive 13 over 24. So positive 13 over 24 x raised to power 4. So you see, here you getting what they wanted you to get. Are we together? So once you are able to find that, then it means you are done with the entire problem.